Hello and welcome to this exercise. In this video, I'm going to solve some problems on the force vectors which we covered in the previous sessions. Let's start with the first one. Two material men try to relocate a big box depicted in the figure. The first man exerts force F1 equals 500 newtons and second one exerts the force F2 350 newtons. Determine the resultant force components, its magnitude, and angle it makes with positive x direction. So basically, in most of the problems you face with such figures, but you have to analyze and break down the figure to a straightforward schematic configuration. So in this case, we can break down this figure in only the configuration of vectors. So I'm going to do that. So this is force F2. That creates the angle of 60 degrees with respect to horizontal direction. And this is force F1. As you see here, these two forces are not concurrent. But we assume that this heavy box is a rigid body. And since it's a rigid body, we can apply the principle of transmissibility to find the resultant vector of these two force vectors F1 and F2. If you remember, in the previous tutorial, I highlighted the application of the principle of transmissibility, and one important application is that it allows us to find the resultant vector even if the component vectors are not concurrent. So this is the line of application of force F2, and this is the line of application for force F1. Therefore, the vectors F2 and F1 are like this, and since they share the same initial points or tails, we can use the parallelogram law of addition to find the resultant vector. So I sketch a virtual parallelogram, and the diagonal will be the resultant vector R. So easily I can write down the formula of magnitude F1 square root of F1 power 2 plus F2 power 2 plus 2 times F1 times F2 times cosine alpha, which here is 60 degrees. The angle between two vectors F1 and F2. I can substitute the values in the formula. F1 is 500 power 2 plus f2 is 350 power 2 plus 2 times 500 times 350 times cosine of 60. So the result will be the square root of 547,500, which will be 739.93 newtons. That's almost 740 newtons. So the magnitude of the resultant vector is 740 newtons. The next step is to find the x and y components of the resultant vector. So for that, I consider 2D plane x and y. So the x and y components of the resultant vector are the pictures of f1 and f2 on x and y directions. So first let's consider x direction. On the x direction, there is f1 and the picture of f2 on the x direction. In other words, the x component of the vector f2 is vector f2 cosine 60. Since f1 is horizontal, so it has only one component along the x direction. Now, let's consider the y direction. We will have only one vector along y direction, which is the y component of vector f2, which is f2 sine of 60. With this in mind, I can write r is equal to the x components f1 plus f2 times cosine of 60 I plus the y component is f2 times sine of 60 j. Remember that I told you in the first tutorial on vectors that these brackets are considered as scalar quantities. So I can sum them up using algebraic approach. Therefore, the vector r will be $675I plus 303.93 0.11 J. So this is the x and y components of the resultant vector R. The last thing the problem asked us to find is the angle that R makes with the x axis, the positive x axis. In order to find that, again, I'm going to sketch 2D plane x, y. So this is R, and this R has certain coordinates on both x and y axis. So this is ry and this is rx. I know the amount of the resultant vector R on the x-axis. I have already found it, which is 675 units. And the value of R is its magnitude. So basically, here we have a right triangle that I'm going to find this angle here, which is the positive angle with respect to x direction. From trigonometry, I can say the cosine of theta x is equal to the adjacent side, which is rx, or the x component of R, which is 675 over the magnitude of R, which is 740. Now, theta x is equal to R cosine of 675 over 740. That will be 24.22 degrees. And this is the angle that the resultant vector R makes with positive x direction. As you see, in this problem, it was solved based on our knowledge of vectors. So without this knowledge, without figuring out the addition law, the positional vectors, the angles, and also the principle of transmissibility, it couldn't have been solved. So we found the magnitude for the resultant vector R, which is 740 newtons. Then we found the x and y components of the resultant vector, and finally we found the angle that the resultant vector makes with the positive x direction. Now let's proceed with the second problem. Two compressive and tension forces are exerted on point O of a wooden structure. Determine the resultant force of them. First of all, as we did in the previous problem, we have to break down the figure into straightforward and simple configuration. So here O is like a pivot one force vector with magnitude of 3 kilonewtons as compressive force is exerted on O, and the second one is a vector with magnitude of 2 kilonewtons, which is tension. So the problem has given us some information like the magnitude of vectors, the angle that one of them makes with x-axis, and the trigonometric proportion of one of them that paves our way to find the angles. As you see on this schematic that I just sketched, to find the resultant vector in this scenario, we have to use the triangle law of addition, because the tip of the first vector shares the same coordinate or same point with the tail of the second one. So the resultant vector is R that connects the tail of the first vector to the tip of the second one. In order to employ triangle law of addition, I have to know the angle which is here. A portion of this angle is known, which is 30, but the second one here, alpha, is unknown, but I can find it easily. It's a piece of cake, because alpha, based on geometric definitions, has the same value in this figure. So to find alpha, I employ the tangent function of trigonometry for 3, and this is alpha. Tangent of alpha is equal to the opposite side, which is 4, over the adjacent side, which is 3. Alpha is arc tangent of 4 over 3, where it will be equal to 53.1 degrees. Now we can use the triangle law of addition formula because everything is clear and known. So R is equal to 3 power 2 plus 2 power 2 plus 2 times 3 times 2 times cosine of 30 plus 53.1. And the result will be 3.8 kilonewtons. It was a piece of cake. So we employed vector laws. Then we found the angle between two vectors based on geometric and trigonometric rules, and easily we substituted the values in the formula and the result appeared. Now let's go to the third and last problem of this session. A flagstaff on a rock is connected to ground at two B and C points with two wires. Wire AB, this one, has tension force of 8 kilonewtons. Determine the tension force of wire AC, this one, in a way that only a downward force at point A appears. So basically, like usual, my recommendation is to break down the figure into straightforward and understandable schematic depiction. So this is point A. Two wires grabs the flagstaff to hold it vertically. You have seen many times, not only in flagstaff cases, like for example transmission towers, that the cables are used to hold them vertical, specifically in the case of transmission towers, because they are subjected to wind and gravity and different forces 24/7. So these cables hold them and attenuate the devastating forces. The point A is where the wires are connected, and those wires grabs the flagstaff at the point A. Of course, the forces must be tensile to hold the flagstaff. I name the forces and their vectors TAB for the wire AB and TAC for the wire AC. AB is now, which is 8 kilonewtons, but AC is unknown. The key point of this problem is the last sentence. It says, in a way that only a downward force at A appears. It means that we don't have horizontal forces. So this is a key that opened the door to solve this problem. So we will have only a force vertically at point A. Since we don't have horizontal forces, it means that the horizontal components of these two force vectors, TAB and TAC, must be zero. In other words, their interplay must give us a null resultant vector along the horizontal direction. But first of all, I have to find those horizontal and vertical components. On the figure, I have some dimensions, but the most important part is to find these angles. I name them alpha AB for the wire AB with respect to the vertical direction, and alpha AC for wire AC with respect to vertical direction. Now I can use my geometric and trigonometric knowledge to find these two angles because the dimensions are given. I have two right triangles. One of them is this one. And the other one is this one. So, to find alpha AB, I can use the function of tangent. So tangent of alpha AB is equal to the opposite side here is 40 over the adjacent side. On the Flagstaff, the adjacent side is not given, but this is the sum of these two dimensions, which is 30 plus 20 equals 50. Alpha AB is nothing but arc tangent of 40 over 50, which is 38.66 degrees. So alpha AB is noun. Let's find the angle alpha AC for the other right triangle. Tangent of alpha AC is equal to the opposite side here is 50 and the adjacent side is 30. Everything is clear on the figure. So 50 over 30 will be alpha AC is equal to arc tangent 50 over 30, which will be 59 degrees. With this in mind, now let's find the tensile force AC. As I mentioned, to solve this problem, as it is stated, the horizontal force components at point A have interpolate in a way that the resultant vector of them along horizontal direction is 0. So this is point A. Now I know the angles. This is TAC times sine of alpha AC, and this is TAB times sine of alpha AB. These two forces must be equal to have the resultant vector equals 0. So TAB times sine of alpha AB is equal to TAC times sine of alpha AC. TAB is now, it's 8 kilonewtons times sine of 38.66 is equal to TAC times sine of 59. Easily, TAC will be 8 times sine of 38.66 over sine of 59, and the result is 5.83 kilonewtons. TAC now is available. The last step that must be taken is to find the vertical resultant vector at point A. So once again, let's consider point A where two wires are connected. In this time, at this time, it will be the sum of the vertical components of two force vectors TAB and TAC. So this is R. R is TAB times cosine of alpha AB plus TAC times cosine of alpha AC. Everything is now. We only have to substitute the values. 8 times cosine of 38.66 plus 5.83 times cosine of 59, and the result is 9.25 kilonewtons as the sum of two vectors TAB and TAC along vertical direction. This problem has been solved. It was just an exercise to understand the concept of force vectors, which will be used frequently in all statics problems.